Hello there, everybody, and welcome to this ceremony of the final project presentations from our students of the Robotics Developer MasterClass 2022. So today we are going to have two presentations from our students Chris Paliqaw and Salvatore Volpe. Super interesting, both of them. So yeah, stay tuned, and I hope that you are going to enjoy them. My name is Alberto. Here I have Ricardo.
Hello, everyone. We are ready for the final step of the master class of this. This has been for a year. So all the students that are presenting here today, they have been studying a year because they have opted by the non-full-time part of the master class. Then they have been struggling and learning and doing a lot of stuff in order to reach this point after a year. So that's the final step. I wish to all of them the best of luck and that they are going to succeed. And then after this, it's going to be the going to NASA, going to work to the best places of the world.
Yeah. So yeah, let's see how much they have learned during this whole year. So the first presentation, let me introduce it. It's going to be from by Chris Paliqaw, and he's going to show us this ROS1 JWT, which is a ROS1 service that validates user permissions from a JavaScript Web Token. So let me...
That's a nice name for the title of the presentation. It looks like the name was just... at the beginning, I thought it was random, but
yeah. So
let's
say hello to Chris very quickly. Hello, Chris. Are you ready for the presentation?
Hello. Absolutely.
All right. So you can start sharing your screen whenever you want, and the audience is all yours.
Okay. Sounds good.
Let's see. Let me see confirmation if the audience is listening to you properly. So can you confirm, Sonia, can you confirm that the sound, it's okay? Okay, perfect. So everybody is listening to you. Chris, you can go ahead.
Okay, sounds good. Let's see. It's been a while since I've used PowerPoint. Let's see. Okay, so I'd like to talk with you today about ROS1 JS, its current shortcomings and ways that I'm looking to improve it to fit the needs of Robotic. And I work for Robotic right now. So here's the issue. So ROS1 JS is a great library. It allows you to access ROS through a web browser using JavaScript. But here is the problem. Essentially, when you connect to ROS through a web socket, and then once you have access to it, you basically have unlimited access. And so right now, once you connect to the system, there's not a really good way to restrict what you can do in the system, say, based on something like what topics you can look at, if you can monitor the robot, or just or if you can control it. So I'm looking for a way to do that to meet the needs of Robotic. And we would like to, just for instance, to have perhaps someone is able to monitor the status of the robot and the other one might be able to create new behaviors of the robot or remote control the robot. So this is kind of the example. Basically, you can see in this web screen that I'm directly entering commands into the browser console to control the robot. And you can see right here, I've actually made the robot crash. So I put in an extremely irresponsible command. I made it go way too fast. 0.5 is just way too fast for the robot because, perhaps I was someone who really shouldn't have been allowed to do it, or maybe I'm just a hacker because we have this little function I made, send hacker topic message. So I shouldn't have been able to do that. So you can just kind of see, basically, this is all stuff that you can put directly into the console if you have a connection via WebSocket. So you can basically go in, create your own function that basically connects directly to the topic for command velocity. So this is the structure that I've created. I haven't implemented all of this yet, but I have fully implemented the ROS-auth JWT component. And so essentially what I propose here is you have your React client, or this could be any other JavaScript client, or even, it could be Flutter or anything like that. And so this is going to connect to ROS Live.js, and in turn, that's going to connect to ROS Bridge Server. And so right now, these things are a common way to deal. Basically, kind of this through line is the common way of using ROS Live.js in an app. And it basically means that you might be able to have some sort of password protection on basically getting a WebSocket connection, but that's about as much as you can. And there is a current ROS-auth service that's available in ROS1 that hasn't been ported yet to ROS2, but it only allows Mac-based access. So essentially, there's just a secret file, and so if you have the secret, then you can access it. So it's a fairly binary thing without any fine-grained user permissions. But what I propose is basically a ROS Bridge server that's going to have a JSON file that's going to know about the different users in the system. And so based on the user permissions, it'll have access, because ROS Bridge server is really kind of the gatekeeper that's going to stand between the user and the ROS system. And so as another thing, basically how I'm implementing this at Robotnik is it's going to use Supabase, and that's really just going to supply authentication services and database services. But this kind of architecture will work with any authentication provider you want and any database provider, because basically the ROS-auth, it only depends on JavaScript Web Tokens, which when you get them in the end are really just a string, and then you are able to validate those using a secret key. So this is what I said before. So ROS-auth, as it exists in the standard distribution of ROS1, is very, very simple and doesn't have fine-grained permissions. So far I've forked the ROS Bridge suite, but the only thing I've done so far is just add a new message type, a new server message type, service message type that will take a token and extract information to it. And so this is, like I said, again, this is Supabase. This is the backend as a service provider that I'm using. And as an aside, one reason that I'm using Supabase for the current project at Robotnik is because, unlike its competitors, it's open source and it allows self-hosting. And in a lot of robotics applications, that's really critical because, for instance, we at Robotnik, we have inspection robots, and we can't rely on being connected 24/7 to the cloud. We need to just be able to rely on being connected to the local area network. And I think for a lot of other robotics applications, that's really critical, because if you're any sort of robotics manufacturer and you want a system like this, you need to make sure that it's going to be flexible, and you might assume up front that you can be connected to the cloud, but that's not necessarily true. And maybe your needs will change. And this is similar. So as an aside, basically this approach that I've taken, I started with ROS1 just because right now at Robotnik, we still are primarily using ROS1 in our production robots. But when we do move, I made sure that this approach will work in ROS2 as well. Basically, the JS library has already been ported to ROS2. And the great thing is the ROS2 will offer even more features and can even be even more secure. So, for instance, the ROS2 DDS will allow fine-grained restrictions on access to different topics and services and actions, just kind of embedded inside the ROS2 system. So that's an extra level of protection besides the ROS bridge server. So that'll be great. And but for now, I believe that just using JavaScript Web Tokens, we'll be able to use the same web token to both control access to the database through Supabase and its Postgres SQL server, and also control access with the same token to the ROS system. So right now we can take a look at how we run this. So hopefully you can see, I'm going to right now switch access to, I'm going to just change what I'm sharing here. Let's see. Okay.
We are seeing you now, Chris. Okay.
Okay.
Now we can see a
now
project. Yes.
Okay, now I'm going to the ROSject. So here's I'm going to start with the usage of the service is actually quite simple. I've tried to really isolate its functionality and not, and that's similar to how ROS auth works itself. The original, I've studied that. That was a C++. I've implemented it in Python for now, but in the future, I'd like to probably port that to C++ now that I've experimented with it and validated the concept. So right now, I'm just going to be installing Docker here. And that's something that I've definitely moved to myself. I try to do all of my development in Docker. It just makes things a lot easier. I've been working on my local Mac machine, even though it's a Linux. It's obviously all based on Ubuntu here. But that was no problem. And I was able to get it working in the ROSject in a very short amount of time with just about 10 minutes of work with no fuss. So that was pretty amazing and something that, so I would definitely recommend Docker is definitely your friend, even though it can be unfriendly to start with. Definitely a good investment of your time. So essentially just here in the ROSject, I have to install Docker here. And then soon we can move to more interesting things. Okay, so I think should be good. Let's see, we're here. Okay, let me try that one more time. Let's see, I'm having trouble here, so I think I'm just going to move to my local box. So no worries. Okay.
Now we can see you. Not
yes.
your screen.
No problem. Okay. Now I'm moving to Visual Studio Code. Okay. So, I think I'm just going to share my entire screen. It's taking up too much time. Let's just do the whole thing.
We'll let you know if we are seeing something that we shouldn't.
Okay. Okay. So, to start with, so let me just see here. As a quick start, you can just see how the service works. I know it's a lot of jumble here, but the service is already up and running on my own box. So essentially, I do a ROS service call to verify to the verified JWT, and then here is a token. And so this is I'll talk later about where I got this token from, but you can see here. Let's try it. So here we go. Signature is expired. So this is important. So we basically, right now the ROS auth JWT service basically says we are not authenticated. It doesn't really care about our email, doesn't care about our user groups, and it gives us an error message. And so the library that I use is really great. It's PyJWT, and it has really nice user-friendly messages that you could even put directly. You could even give directly to a user because they're using plain English. So essentially, here's our service here, and this is all run in a Docker. This is Dockerized, so now, yeah, let me talk right now about where I got this from. So as I said before, I get this from Supabase. So let's actually look at, right now we can actually look at the README file for the ROS auth JWT service that I created. So essentially, here's the start. This is the only thing I forked so far from the official ROS distribution. So ROS Bridge Suite. And this was just because I thought the best place to put the service message was in ROS Bridge Suite. So you can see here is the verify JWT. So we just take a token, and like you saw in when I called the service, we get whether we're authenticated or not. We extract the email, and then we also get user groups. So that's something we're going to see when we actually do this successfully. So this is just talking about how to do the Docker run file. I have a script for running the project in a Docker file. And all you have to do to install this, you basically just, the only tricky part is just making sure you have my fork of the ROS Bridge Suite and you have the verified JWT branch. But then everything else will use ROS step to pull down all the other dependencies because they're all standard. The other trick as well is I had to get it to work, to get my project to work with ROS step, I also had to basically do a fork of the ROS distro in order to use the PyJWT library. But that's actually something I'm debating. I might, in fact, go to a library that's already in the ROS distro, just because I've had some clashes with the cryptography library that are already in the ROS distribution. So the essential thing here is when you are running this project, this is a library that is not in the GitHub repository. So you're going to basically have to put the JW key. In this case, it's something I get from my Supabase project. and then you just say which algorithm you're using. The library will actually auto detect it, but they strictly advise that you don't want to let it's a security vulnerability to have it auto detect. So I make sure that's actually a check in my code to make sure that we're using the correct JWT algorithm. The audience isn't something you really have to worry about. It's just part of the tokens that Supabase uses. They just call it authenticated. Then you're also going to, when you're running the node unit tests, you're going to put in an old token. So that's just, you want to make sure you have an old expired token, and then you want to get a nice fresh token. So inside of our Supabase project, we can go and pull down the API keys we need, and essentially you can also set an expiration time for the tokens that you're getting out of Supabase. And I just basically did them for an hour. You don't really you want to make sure that if you need to change the user permissions of a user, you don't want to give them a super long expiration time. So they have to, so you can make sure that they're still belong doing what they're doing. So right now I'm actually going to generate a token. The current process that I have is fairly wonky. So basically it's just a test. It's a very, it's not a robotics thing. It's just, I've been learning, I've been trying to improve my Supabase and React skills. So this is just part of a course that I was doing that I have changed from using Firebase, which is by Google, but is not open source. So I basically converted it to use Supabase instead. So right now, I'm actually just going to go ahead and open that app. So it's just, you can see that it's just kind of a standard sort of clothing sales app. But I've modified the source code so that it prints out a token in the console. So I'm just going to do a Google sign in. Obviously, that would not be a good idea. I can't use that in our production app for Robotics, since we can't rely on Google authentication, which must happen in the cloud. But it's definitely easy for now to do that. So right now, I'm just going to copy this token, and so right now I just going to put that here in my screen. So I'm going to paste that in. So the first thing we can do is we can actually try now to do just the ROS service call and do it right this time. We just paste that in. Let's see if it works this time. Okay, so that worked this time. So now we get authenticated true. It gives my email address, and it says that I'm part of the group's monitor, and there is no error. So that was successful. Now, so basically, if you are going to do this test, you never need to replace this one, because this can just be a stale one. But of course, this isn't an ideal way to test either. What I'm basically doing, it's not a very good blend between an integration test and a unit node test. What would be better for just testing the service was that if I could, you can see here the tests that I have. It would be better for just testing the service itself if I just signed the token myself and then read it out, basically just kind of do a round trip. But for now, it was useful to start with doing that from Supabase just because I needed to demonstrate that this would actually work correctly. And I actually had quite a bit of trouble pulling the token out of Supabase. It was very easy with Firebase, but because it was an asynchronous call, it was actually quite tricky to pull the information out. And the API wasn't really well documented, unlike the Firebase. So that is kind of a danger you get, with a newer service like Supabase, vice Firebase, which is really the industry standard, especially for mobile apps. So right now and so this test is actually using unit test, which is the default for ROS1. For ROS2, it uses PyTest, which is definitely superior, but I tried to get PyTest working in ROS1, and I wouldn't recommend it. I think that you're a lot better off using the standard solution that's supported by Open Robotics. So anyways, I think we're ready to run the test. So I can actually kill this right now. I can kill the service. And now I need to actually go into the directory. And so as you can see from my instructions here, let's look at my instructions for testing. So all we need to do is if you have a new terminal, you'll need to run docker exec, which basically just goes into the container and sources your ROS installation. But this is once you're in the directory, this is the only command that you need to run. So really nice. We could run, I'm only going to do it for this because otherwise it's going to run tests for ROS Bridge Suite, which contains several packages. So that's why in this case it's better just to run just for this package. And so yeah, we have success. So now we can kind of look at what I actually did here. So we basically have a Python class with let's pull that back a little. Surprise, Python lets me do that. So basically this is just a simple class that stores the token and then the error message we expect, whether we expect it to be authenticated or not, and then a Python list of user groups. So we can basically see we have a token that is utter nonsense, and we expect it to just say this is just not even a valid token. We expect it to be, not give us any more information. And then we have our old token. We have our new token. Then we expect this message, signature is expired. And then we expect when we get the new token to have monitor. And you may be thinking, where did I actually, how did I actually create this token? And this is something that Supabase did for me. So this is a really fantastic thing about Supabase or similar, or its competitors. And there's, I would say Google Firebase is the biggest, but Amazon and MongoDB also have competing services if you're up for being cloud only and closed source. And so essentially we have a SQL editor, and there is a project that I was able to leverage. So this is called Supabase Custom Claims, and this is a community project, but just has very simple ways. It is a bit of a downside of using Supabase. There's still Supabase, the company, is going to have their own official solution. They're still debating exactly how they're going to do it. But this basically is a way to run some SQL on your server to get and set the permissions and make it so that they're embedded in your JWT. So it's really lovely. All you have to do here, you basically have an installation script, and it's going to install these functions for you, these SQL functions. And they're very, I had no problem whatsoever using them. I'm really impressed. So here, once you've installed those, this is how you can do it. So this is, I basically stored the installation script in my project. We don't really need to worry about that. But once you've installed that, this is the only thing I had to write. I basically have SQL scripts to get and set. So essentially, if you want to get the user, all you're going to do is you're going to go in, you're going to find the user ID and just get the user groups. And that's just going to pull out your array out of the database. And then when you're setting the user groups, let's see. Oh no. I accidentally wrote over this, but we can go into this. This should tell us what we need to know. So if we go back into the Supabase custom claims, you can see an example of how to use this. So for setting the claims, all you're going to do is you just get a user ID, and then basically what you're going to set, and then you just have a JSON object. So here's a simple example. So this is, so you actually can do most any kind of JavaScript compatible data structure. So in this case, this is just select, set claim, the user ID, and then in this case, you're just setting an integer. So user level 200. And then this, down here, this is much more akin to what I have. This is even more complicated. So you can set, you can use a full JSON object, whereas I just did a JSON array, which is sort of a medium between the two. So yeah, let's see. So at this point, I think that I've basically gone through everything. The one thing I would say remaining is that we can look at how, we can also look at where we're pulling the user data is from. So right now you can see that I basically stored, these are all my own personal addresses, and I've signed in using Google authentication. And then when I signed in with Google authentication, if the user has never signed in before, they're automatically added to the database, which is not something we're going to want at Robotnik. We're going to want to have to manually add that, but that's just another setting we can do in Supabase. But basically, here's the user ID, and so I can just copy that. So if I were going to run these SQL scripts, this is where I would pull out my user ID. And so another thing I'd just like to remark on is yeah, so this still is a system that I'm working on. So this is just one part of the system. I'm going to definitely have to do more work on the ROS bridge. Going back to my slideshow. So I definitely, so the things that I'm going to need to work on is the ROS bridge server. This is probably going to be the biggest change that needs to happen, just to implement the list of user permissions in ROS bridge server. But actually, the changes needed for ROSlib.js are going to be quite small. It's just basically when it accesses ROS bridge server, the ROSlib.js is just going to need to have a function call in a slightly different format that all it needs to do is just pass a Java Web Token along with the other things. But that's the groundwork has already been laid for that, just because there's already, at least in ROS1, there's already support for the original ROS auth service. So that gives me a really good template for doing what I'm doing. And so I think that is that about wraps up my presentation. And I don't know what the team thinks, but I would be I'd be open for questions or anything else.
All right, thank you, Chris, for your presentation. So yeah, I don't remember. Yeah. Okay. Yeah, so let's let me change the screen here so that we can see you. Yeah, so we have many questions. Let's try to select some of them.
Okay, I want to start myself because I have a key question, I think. And so it was not clear to me what was the goal of the project. So what you tried to achieve, the overall goal.
Okay. The primary goal is to be able to use ROS-libJS and then all of the great visualization, the 2D and 3D visualization libraries that are built on top of that. But to be able to
for what?
restrict, be able to restrict access based on the user, and have it not just based on being polite and following the rules, but to actually restrict, to block information and functions in the ROS system, which is not right now is not a priority of the team that's maintaining ROS-libJS.
Okay, so
but it's something that's important to us at Robotnik.
Okay.
And so one part of that is basically, so if you have anything stored in the PostgreSQL database, that's very straightforward to control, because that is just something that's built into things like Firebase, Supabase, or that's very going to be a common part of any sort of CRUD system. But the goal was to be able to take the same JWT token that we use to restrict access to the data in the PostgreSQL database and be able to use that to restrict access to the ROS system as well.
Okay, so then there is a web page that people can log in order to access to data inside a robot. Is that?
Yes. So an example of the type of system you could do with this is, let's just say you, a common way to do it is, especially if you're worried about access to the cloud. Say if you have full access to the cloud, this could be on an external server. But in the case that you want a kind of a simple networking setup, the server would actually be running on the robot itself. Basically, the web server would be running directly on the robot. Then let's just say you have an inspection robot. So you could log into the web page on the robot, and then you could say, perhaps you could use something like some sort of Blockly programming language to give the robot a series of instructions, say navigation tasks. It could even be, picking up tasks, charging tasks, kind of similar to what you would do, kind of the stuff that Open Robotics is working on in Singapore. But if you're just using ROS-libJS, it would be restricted to a single robot. And then you could also use the 2D and 3D libraries that are built on top of ROS-libJS. So you could visualize three-dimensionally what the robot is doing, it would be very similar to what you would see in something like RViz or Gazebo, just on the web page.
Okay.
And then, so then the idea would be, say if, let's just say that you are a foreman at the factory and you're doing inspections. You could run already pre-existing sequences of commands. You could check the status of the robot, but then the technician that would be say the consultant that would be the actual roboticist, the robotics developer might be in charge of creating those sequences.
Yeah.
Or you could have someone at the company that would know how to do that would be qualified to do that.
Okay. And then they will use a web interface to interact with the robot in a simple manner. And for that...
And that's correct.
And then for that, you need all this structure in order to provide access to the people, to that interface, to the people that actually deserves to have this, right?
Correct.
Okay. And then...
Sorry, go ahead.
No, just go ahead.
But I also want to note that the web interface is the most straightforward way to implement it. But you actually a while ago, I actually posted a thing. At the time I was really interested in creating iOS apps that could do something like this. This was before I started the MasterClass, but Téllez from who's been part of the team for a long time, he just said, "Oh no, you don't need any iOS library. All you have to do is put it in a what do you call it? I'm blanking on the name right now. Yeah. But basically, you just have like one web window. You basically have one web, and you can use the ROS1 using Flutter or iOS or Android desktop
to show ROS information on any graphical interface, let's say.
As long as you basically have that JavaScript window, then you have full access to the visualization libraries.
Okay.
So you don't need to, as long as you can just talk back and forth between the JavaScript and your native environment.
Okay.
You're not restricted to doing web things like, say Ruby on Rails or PHP or React.
Okay. And then in that structure that you have, then the Supabase, what is that actually for? So what is why do we need Supabase in all this?
I think one way of thinking about it, I think it goes back to my background in mobile development. So it is totally fine to just say you could just do a mean stack. So the mean stack would be MongoDB, Express, Angular, Node.js. That's perfectly fine if you want to implement it. And the components that I'm creating are going to work perfectly fine for that. But a backend as a service gives you really nice out of the box API support for authentication and database storage. It basically gives you really nice APIs, and they have done the work for you. As far as securing the system, you don't have to be an expert in that. They're going to give you that out of the box. Okay. That's just one less headache for you.
I see.
And that's just something that is very common in the mobile programming world. So say if you're going to do native iOS development, you're going to have core data. We'll have some of those services. Say if you're in the Android world, Firebase is common. And also, I think a key thing to note is it also why I chose this particular solution is just trying to simplify the training needs of a company. Because if you're, basically if you're a VC thing and you have, $2 million to spend on this project, then you may want to do your custom thing. You can create your own visualization library. You're going to basically go back to those JavaScript libraries or, maybe you could do something with Unity, pull that in. But this way you can basically have a one language solution. So if you want to go JavaScript, you're going to be able to only use JavaScript. And you're not going to have to go into even Node.js. It's all front end code. You're not doing any back-end code. You can basically, inside your web page, inside your React code or something like that, you're able to do all of your database, all your authentication. And it also is very similar in the style of programming that ROS-libJS already has, which is basically, front end only. You're not trying to pull in different server code and stuff like that. And that's really nice because you can bring in, I think as far as training someone on your team to do this, you can basically get the basics of ROS, maybe do the constructs ROS basics in 5 days, and then you have a skilled front-end programmer and you don't need anything else. They just have to know a front-end framework and they can do everything. And they can learn something like Supabase or Firebase very quickly.
Okay, let me ask you one final question. So you mentioned that you have Dockerized all these projects. So can you tell me which Dockers have you created and for what? Which Dockers are you using, launching? Is only a single Docker?
Sure. Oh, go ahead. I didn't hear the last part.
Sorry, it's only a single Docker for your whole project, or you have several Dockers, each one is with one service, and you communicate between all of them? How does it work?
Yeah, and to start with, I think I am going to want to improve the Docker. I think just for the purposes of education, I wrote my own Docker file, but it does need to be improved a little, just so that right now you can see that when I start up the Docker file, I have to compile everything manually, but that should all be done automatically.
But I mean, which services are you launching, or which programs are you running in the Docker? Is a single Docker that runs all the stuff that you need, or I don't know?
Right now, essentially, just for the purposes of testing the ROS-auth JWT service, all it's actually doing is just pulling in the dependencies. It's basically, I already, just because I ran the fork, it's basically just pulling in the dependencies. And the only thing that it's actually, the only component that it's actually running besides ROS core is just the service. So it's all the Docker file is doing is basically getting the ROS distribution on top of Ubuntu 20, and then pulling in, basically running ROS dep. That's about all it does.
Okay, isn't a big Docker then at the end? So you are saving because you are saving and you are sharing this with your Docker account, I presume, because you mentioned that you are using this also on your Mac. So you are pulling this Docker from the cloud at some point in time?
No, it's the only external Docker file. I haven't, put this on in a Docker repository of any kind. This is just on my GitHub account, so it's actually a very small Docker file. I can actually show that. Why don't I just show it right now? I'll share.
Yeah, you can. Sure. I will change this so we can see better.
So, yeah, let me just pull up the right Visual Studio window. And so, yeah, just as a preamble, this is missing a little bit. This could be a little bit more complicated just to do the cat can build, but it's quite simple. So I'm just basically, this is from ROS Noetic. I'm doing an apt update. I'm just installing Python 3, installing pip. And that was just so I could install the catkin tools. I prefer using catkin build to catkin make. The only thing that's tricky here is that I actually have to override the ROS distribution. And so that's actually something I forgot to talk about. I actually had to go, in order to use the JWT library and have it all done by ROS dep, I actually am overwriting a file. I kind of did this automatic. I'm overwriting the ROS distribution in order to do that. And I actually did talk to the team that manages it, but like I said before, I think I'm actually not going to be using the JWT because it's too hard to get the cryptography libraries to jibe correctly. So I'm going to be using another library. It's not quite as full-featured, but I think it would just be better to use something that's already offered by Open Robotics by default instead of trying to use my favorite library. So that's basically it. We can see the Docker file again, but so that's about it. And then, essentially you're just going to use bash here, and then you're just going to start in the Catkin workspace, and that's it. But what should happen at the end here by default, just to save time and make it better, I should add the, basically the compilation step of, running catkin build and that kind of thing. But that's going to be stored on your development box, but you don't need to store it in the cloud. And this is it's pretty fast to create the image for the first time.
I thought that you were sharing the Docker with other machines, not only your laptop. So, and then in that case, you need to push it into some place in your cloud and then recover in the other machines. That's what I thought. That's why I was asking you. But don't worry. So it's clear. It's clear. Then let's go to another question, Alberto. You have?
Yeah.
Okay.
So, for instance, one thing that I didn't understand is in this architecture diagram that you showed, there is one part which you are referring to a JSON file, which it's the one that map user groups to permitted ROS functions. So I understand that this JSON file is where it's basically where you are going to tell the system if a specific user or a specific user group can do something or can access to some specific data or he can't. And is there an example of how this JSON file would look?
Sure. And actually, now that I'm just thinking about it on the fly, this is something I haven't implemented yet, but I think it would be quite simple. So yeah, we can even do this on the fly. I don't think it's a problem. So let me just share my screen again. And so this is the first time I've attempted this, but
yeah, no,
just give it a whirl.
Yeah.
But I can I'll just give you a really simple example here.
We can see your bank account.
Oh, that's probably nice. Good. If you could edit that out later.
Okay.
Let's see. Let me do a simpler. Let's see, a less dangerous program here. Okay, so let's just say we have something like this. So we could have something like, admin, something like this, admin, and then, verify like service, ROS. Service
is self-correcting everything all the time.
Yeah, don't worry.
We understand. Maybe we should use okay, yeah, but that's the basic idea. So you're going to say like admin can access ROS service verify JWT, and then basically monitor is going to be able to do like the ROS topic, something like I don't know, what would it be an example? They're going to be able to monitor the point cloud, say service or something like that. They're going to be able to access that. So yeah, is that clear now?
Okay. Yeah, and all right. Yeah. Okay, and also I saw another question there, and also I wrote it here just to clarify also this point. So because from what I understood, the main improvement from with this ROS out JWT with respect to the ROS out regular one is that this one is using these JavaScript Web Tokens. But can you explain more what is the improvement?
So it's basically just saying it's password based vice something that is JWT based. So essentially the ROS auth, if I understand correctly, it basically just, you can basically have a single, I guess this is how I would say it. So it's just going to be a single password access. You know, you basically have a robot, you either have the password or you don't. There's no fine-grained user access. But you can basically take the JWT, and then in the JWT, you can say whether it's expired, whether you can know that they've logged in recently, that it's a fresh login. You can also know who they are, and you can know on a fine-grained level all of the permissions that they have. And that's not possible with ROS auth. It's just going to be a single password. Mm-hmm. And it's, you know, you're going to have to go and manually edit a file on your robot. Whereas the other things, it can be managed directly through Supabase or PostgreSQL, or, you know, whatever method you're using.
Okay, and I'm going to ask...
And it can also be unified with your database access. So you can use the same security system for storing data in your MongoDB or your PostgreSQL database that you're using for your ROS system.
Okay. Yeah, and I would like to ask one last one from my side, which is you talk also about how would be to port this to ROS2. I think that you said that it would be easy, so the architecture would be the same. You can port the same architecture, but I also read somewhere that even there is some potential to enhance the security with these DDS protocols that ROS2 is using.
Yes. So the DDS thing, I think I would definitely have to think about exactly how that would be implemented. But I think that you could have, it would be really more about implementing redundant security. So the main thing for just doing exactly what you're doing here, if you're not going to do any DDS, it's really, there really is no difference. Essentially, you're just going to take ROS auth and you're just going to write it using your, your client libraries for ROS2 instead. It's just a straight up translation. There's no, it's just straight up the same, exactly the same. And ROSlib.js already fully supports ROS2. So as far as the DDS layer, essentially the DDS allows you to, it's definitely not like a very cloud-based security system. It's much more based on storing security tokens in like basically hard files that are in the file system. So say if you could say if you wanted to do this, you could have multiple ROS bridges. I don't know exactly why you would need this, but you could basically say that your ROS bridge, it's in this larger ROS system, but you could actually make it so that the ROS bridge server itself does not have access to a lot of things. So you could basically do a further restriction based on users, but even ROS bridge wouldn't have access because of the ROS bridge server would lack DDS access to different parts of the ROS system. Does that make sense, or would you
need
clarification on that?
Okay. Yeah. Okay, so I think, I don't know, maybe we should leave it here already.
Yes.
Yes, and go with the next one. So yeah, thanks a lot, Chris, for your presentation.
Thank you very much, Chris.
Yeah, if you can share the project with me now, so that we can have a look later. I can have a look later to that.
Okay, that would be great.
All right. So thanks a lot, Chris.
Thank you. Bye.
Okay, take care.
All right, so we are going to go now with the next presentation, which is going to be done by Salvatore. Yeah. Then Salvatore is going to.
Hello.
Hello.
Now.
Hello.
Hello.
Yeah.
Good evening.
Good evening, Salvatore. Let us check. We
Do
lost.
you hear me?
Okay.
Yes.
Okay.
Just a second,
Hello, Salvatore.
Hello.
Hello. Can you please turn on your camera?
Yes.
Okay.
Yes.
Okay.
All right. Let's then switch here to.
Okay. Wait. We have to kick out Chris.
Yeah.
Because he's mixing in the presentation. So yes. Yeah. There it is.
Yeah. Here we have Salvatore. Can we all hear Salvatore?
Hello.
Yes.
Hello, everybody. Good evening.
Hello.
Yes, we can hear you here on the studio, but
Let's confirm that our audience can hear you properly from the YouTube stream.
That, by the way, we already have on the YouTube video, we have already 3,000 views, right? People, so Salvatore, no pressure, but you have a lot of people looking
Okay,
for
yeah,
you.
we have the confirmation, everything is fine.
Yeah.
So, yeah, let's, the audience is all yours. You can start sharing your screen right now and start showing us your project and explaining us about it.
Okay. Do you see my screen?
Not yet. We are seeing you now.
We see you. Yes, well, that's the typical things that happen when you are trying to do something online, remotely, live.
Yeah, it's going to go well because we tested it just before with Salvatore. So it's it's in the Zoom meeting, Salvatore, like
Yes.
we did before. You should have the share screen thing.
Yes.
Button at the bottom or icon.
I try again.
Maybe
Now
it's
we are
getting
seeing it. Now we are seeing it.
Okay.
Okay, great.
Perfect.
So all yours, Salvatore.
Okay. Good evening, everybody. I'm here to present my master work in robotics that deals with a mechanical workshop inside a smart factory. I have a presentation about. I speak about a short overview in the fourth industrial revolution, push the manufacturing industry in integration with the newest technology like artificial intelligence, additive manufacturing, augmented reality, and IoT. This revolution includes an advance in connectivity between machines, robots, sensors, and give rise to the well-known smart factories. The following project refers to a smart factory in which the IoT, the advanced connectivity, and the ROS technology allows an autonomous management of the raw and the waste materials. In particular, the environment that you see in the figure allow an autonomous management of the raw and the waste materials. And you see in this figure a mechanical workshop for working metals with numerical control machine, where the autonomous mobile robot Pallet trucks ensure the handling of both raw or semi-finished pieces and the transport of residual and metal shaving. You see at point 1 the mobile robot. At point 3 you see the full bin that contain metal chips. At point 4 you see empty bin, and at point 2 you see a mechanical CNC machine. So this is the environment, the scenario of my project. The goal of the project is to create a cycle in which the CNC machine calls the robot when the bin is empty, is full. At this point, the robot navigates autonomously near the point of the bin, localize the bin, fork the bin, and move the bin to another place in which someone take to replace the bin. After the robot moves to reach an empty bin, come back to the CNC machine. This is a cycle, an entire cycle of the replacement of a bin. To do this, I used and I built this panel. Is a web page that an operator can use using his smartphone. Every button, a colorful button, have a function. For example, here you read go to full bin is the first button to reach the bin. In this first application, the bin is not selectable. I do a first implementation with only one bin. And I can see that this project is created using ROS1 Noetic in using also Python language. And we can divide the project in 4 main parts. First of all, I created the gazebo simulation. After, there is a chip bin management, the navigation when the robot moves from point to another, and the usage of the package. To reach this goal, I created 9 packages, and I divided these packages inside this list. For the gazebo simulation, it's need two packages, description and environment. Description that contain the geometry of the robot, environment, the geometry of the environment, sure. And after the chip bin management contain 4 packages, detection of the aero pallet. When I say aero pallet is also say to chip bin, because the bin stay on the aero pallet. After, there is the rendezvous. Rendezvous is the package to thanks to the robot fork the bin. Disengagement is the reverse, and after There is the web page that is not properly a package, but it's a folder, etc. After there is navigation, navigation. I create 3 packages, but it's important to say that the function come from a library of ROS, and usage is the last chapter. And here you can see image of the whole structure of the nodes and the topic of my project. You can see better the particular because it's very big, so we can see after in real time the screen. Okay, for the gazebo simulation, I created the robot and the environment. About the robot, the geometry and all is contained in the MR description package. You can see the structure of the folders, and we can see all the file. Sure, but we can speak about the an important file that is the MR Chakro. MR Chakro is important to create the geometry. We can start about the figure 2.1. You see the CID of the CAD, of the robot. The main parts are the wheels, the chassis. The point 2, you see the flashing lamp. Point 4, you see the fork, and point 5, there are the caster wheels. So the main part are this. There are two lasers, front laser, rear laser. I used the two lasers because one is for the navigation and another is the localization of the pin. It's important to say that one have to be a more resolution respect to the other. In particular, the rear laser scanner have a field of view of 60 degrees, so have more resolution than the first one, from laser scanner. Because in this way the frames are that the robot create to localize the raw pallet is more stable, precise and more stable. Another important figure is this, when you see more or less the main dimension of the robot to understand better. The geometry is created using the Chakro technology because it's very powerful because allows to use parameters and macros. The macros is useful when it needs to repeat parts like driving wheels and caster wheels. And the parameter is important because is more enable to modify some particular as mass, morphology quickly, and it's important because you can't go inside the code to change the value. There is an initial part of the program in which I list all the parameters, and I interact only with this. After the CID I created in PTC Creo. I used the Blender to add the colors. With in particular, it's important to export the file from Creo in STL format and import in Blender and export in Collada, DAE, which keep the colors. And here in this part of code, you can see the Chakro file, in which you see the part useful to create the geometry, the collision. It's important because this is a robot moves in a physical environment like gazebo, inertia the same, visual what do you see. And after there are at the end there are the physical property of the door of the floor, like static contact stiffness, the friction coefficient, etc. And here you can see in the code 2.2 you can see a part of the table of the property of the parameters that I said before. For example, in DWM, I use for say driving wheels mass, and I see this expressed in kilogram. I see assign the value here, etc. So to change the mass, to change the dimension, it's we interact only with this part of the code. Another the Chakro, it's important it's important in general, I think. Transform the Chakro in URDF, because in URDF there is a good, a very useful function that is this one. No, sorry, this is for generate URDF from the Chakro. This one, URDF to graphics, that give a possibility to verify graphically the correctness of the URDF, the geometry. Here in rectangular shape you see the frame, and the elliptical shape you see the joint. You know that the robot is a kinematics chain of link and join. So this graph is properly this. And after, before another step to validate the URDF, the geometry, is publish the map of the transformation. There are a transformation from all the frame inside the robot. So if I want to know distance measured from the laser respect to the central the main frame of the robot, I can do because I know all the chain of the transformation frame by frame. Here you can see the structure of the frame. Before I said about the frame, now you can see the frame of the robot. There are three-dimensional, obviously, three axes in every frame, and the yellow arrow is the connection from the frame. The frame, as I said before, are connected using the joint. The joint let that the frame can move. And for example, another important step is to verify if the joint works or not. And at this stage, this step, it's important because the sensor works in gazebo. It's important to use a fake sensor. This is like this is a publisher guy where I publish in the joint a number, so I can try if the joint moves or not. In this figure, you see that I try to push left the fork. Okay, in geometry, the part are three. There are three parts in the construction. Sorry, of the robot. Three part: geometry, actuators, and sensors. Actuators are used. You see a part of the code. Sorry, the code about the lift. Okay, the actuator are, there are 4 actuators, 2 for the motors. I am referring to the differential wheels, and 2 for the linear actuator to lift the fork. In this code, you see an example of a part of the actuators in which you see the part of code that create the joint, and you see that the joint link to frame. This is the parent, like the father, and this is the son. The joint stay between us, between them. Sorry. The transmission is this, and the transmission is important to move the joint, so to move the frame, and I used the motor, and I used a position controller that I find in the library. The position controller, there is a basic, a simple PID. A good practice to find a good to do a good tuning of the parameter is use the dynamic reconfiguration panel that allow to move the tuning the parameter online. Let me say, you see if you can see if the effect is good or not. In particular, I put I forked the Euro Pallet. I command using CLI I publish a position, and I tried to tuning until I saw a good result. So the lift of the Euro Pallet. Here you can see another plugin that refers to the differential drive controller. You can see that in the main in some position I use the parameter, for example, for the wheel diameter. I use a parameter DWD because for the beginning of the project I try to change this value different times, and at the end I speak about the sensor. I said before I used two different laser scanner. Here you can see better the field of view of the rear scanner that stay in front of the chip beam, and you see at point 1 and point 2 two reflectors. When the light reflects to this mirror, the ray come back with a different intensity. So in this way we can find the corner of the Euro Pallet. The system does different measures, simples different point, and elaborate this. I speak about this before. And this is the part of the sensor, the laser scanner, in particular the rear part. And sorry. Okay, the rear part, the rear scan, sorry. Okay, about the gazebo environment, you can see the structure of the gazebo. Here, I prefer to find in the web the main part, as for example the walls, the floor, the lamp, the person standing. There are Amazon Amazon file in which I found this part. The person is a library of gazebo. CNC machine, chip beans, CNC machines. I find this in the AS website that give the possibility easily to download the CID in a step format. And I find also the chip beans and the Euro pallets. And the main part is to work this part in the Blender environment to give it the color. So the procedure is always the same. Export in STL in Blender, and after export from the Blender in Collada file. This is a part of the structure of the model. Because as you can see, this is the CNC. For example, this is the CNC machine model, and this is the structure. And you can see some particular. For example, in the mesh folder, it's important to put the geometry. And after in the model SDF is the main file in which there are the content of the geometry of the model. And this is a part of the model SDF, in which there is the geometry, there is the inertia, there is the other part. Okay, chip bin, the structure is the same. A particular is that chip bin, when I download from the net, there was the texture, and I work a lot to understand how apply the texture for the container and for the Euro pallet, because Euro pallet is in wood. Another part is to put at the corners of the Euro pallet the reflectors at point 2 and point 5, and after I construct the reacting surface, because this pallet physically interact with the fork. So the fork have a reaction when for example, lifting touch the floor of the not the floor, touch the Euro pallet. Okay, this is the main dimension of Euro pallet. As I said before, a trick to do the mirror is reflect with this tag laser retro magnitude, intensity, a particular intensity, high intensity of the light. In this way, it's possible filter the result, the symbols of the laser, know that something have this value of reflectiveness, let me say. Okay, now you can see also this part of code in which I put the texture to give the appearance or with the wood to the Europallet, as I said before. Here you can say the two chip beans with full and empty and full worked in Gazebo, sorry, in Blender. And we can go on. This is all the code that it's better go on. This is the part. This is the part. This is the part of the Gazebo environment in which I speak about the environment. So in general, for create the robot and the environment. After the third chapter is the navigation. For the navigation, we will see the main packages. For example, for the navigation, it's important for first of all create a map. Create a map of the environment. For this, I used a node that so the mapping, the gmapping node. For the gmapping package, there is a library package. The structure is this, and it's important to understand how we use it, how we configure to create the map. In my application, I created the mechanical workshop map. This is a graphical map. Is an image, practically an image, in which the color have a meaning of the empty space or at the occupancy space. The main configuration of this package is using this YAM file in which for example, I specify the laser that the system have to use to create the map and the main frame. Here I launched when you launch the package, you have to specify the parameters in the launch file or with the YAM file. In this figure, you see the result of the work in which you see the robot that moves inside the environment to create the map. The map, the result of the map are two files. As said before, one is an image, one is contain particular the main characteristics of the map as resolution, as the point, the origin of the map, and some threshold to differentiate the point that are sure in which you have something and in which you have nothing. It's important after the robot have to know the environment by the map and have to be localized itself inside the map. For this, the main package is the IMCL adaptive Monte Carlo localization. That is a package that using this algorithm in practice create an arrow that is called the particle, that is the future pose of the robot. If you see inside the purple cycle, there is a big point, red big point. This is in reality, there are many arrows that are localized all in a point. This happens when the system localizes exactly the point. In different way, you see a big distribution of the arrow. This means that the system don't knows where there is the robot. This is the structure of the package, localization package. After all this package, all this package, it's important. It's important, but the most important is the move base node, because this node provides to move the robot from one position to another. Here there are four main positions. For example, it's important to reach the CNC machine position, on position. It reach the chip bins, and reach the recycling place. And this.
Salvatore, can you hear me?
Yes.
Okay, just to let you know, you have 10 minutes left, okay? So that you organize and you leave some time to show us how the simulation works and all that.
Okay.
Keep going.
Okay. For chip management, I created okay. So for it's important to see the simulation. As if I have time, I finish the presentation. Okay. All right, to the right, you see gazebo. So you see the environment that I said before. And here you can see the point of view of the robot, the sensor. And now here you can see the panel. Sorry. Okay, I'm connected. We are connected with the robot. For example, I want to put the robot near the. I push to go to full bin. So the navigation system knows the position and moves the robot from the home point on position to the position near the. Here you can see that the robot is moving. Now it's a good practice. It's a good practice. Try if the elevator works. No, elevator don't works. Okay, so sometimes the controller don't start. I don't know why. Okay, first of all, we try elevator. Okay, now elevator works. Okay, go to full beam. We can move. We can move the point of view in a different position, so we can see better what happened. Okay, we wait now. The goal of the navigation system is that to put the robot in front of the chip bin. This is the main goal, and after that we okay, now the navigation has reached the goal. Now we use the function that is the one function of the management of the bin. In this moment you see that the laser read the position of the corner, create you see four frames, but the important frames as the frame contains in the longitudinal plane of the bin, and you see here where I am moving the arrow. This is important because the robot now moves his link frame until reach this. So, and it move until reach the longitudinal plane. So in this moment, the algorithm works to put the robot, the longitudinal plane of the robot coincident with the longitudinal plane of the beam. This is the goal. For do that, I can show you better. I can show you better. For example, in this way, you see that now when I have the mouse, the arrow, this is the base link of the robot. I expect that the robot go forward until reach the origin of this frame, because I have to put his base frame inside the longitudinal plane of the pallet. After that, the robot go forward to fork the bin. You can see that I create a server that publish the position of the two main frames, the Europallet frame and the shifted Europallet frame. I think that this work can be done done better using an action server. Because sometimes for some reasons fails. So I think that okay, now we have to lift. We can see mm, we can see this step better in this way. Elevator up. You can see that okay, go up. After we go to recycling, so the navigation receive another goal, and now have to reach another position that is more or less when I have the little hand here. We can see the vision, the laser vision, and we can see that what? No. Go to recycling. Okay. I don't know why, but okay. You can see the path. The path is building using the static map. So the cost map, static cost map, and that you see in the red. The path created, but the global planner is in the red color, but is reached with the local cost map that you can see in green line, yes. And in this moment, the robot moves autonomously, avoiding the obstacle. Okay, you can visualize again this is the main. I'll show you the main. I think that I have no time to see an entire cycle, but yes, to see all the function, because to do the entire cycle, I use again for the bin that I just used before, and I show you the elevator down and disengagement. So you see all the you have seen all the function.
Okay, Salvatore, can you hear us?
Yeah. Yes.
Yes. So time is up. So
Yes.
let me congratulate you. Very nice presentation, super detailed.
Thank you. Okay.
So Yeah, now we are going to make you some questions. So
Yes.
if you can share your camera, stop sharing the screen and share your camera.
Okay.
So that we can see you here and you can answer us.
That's
Yeah,
good.
if you need
Yes.
later to share the screen to explain some point, you can do it, okay? But for now, it's nice if we can see you there.
Sorry, let's see. I interrupt. Okay. I'm here.
Hello, Salvatore.
Hello.
Excellent presentation. I'm impressed with all the progress. I remember at the beginning when you started at the master at the level, and now we can see that the level now it's so impressive there. So congratulations. You show in this presentation that you know the subject. So congratulations.
Thank you very much. For me, it was a very, very hard work, but also a beautiful trip.
Okay, great, excellent. So let's start with the question.
Yeah, so there is one question here. So for when you pick the pallet with the robot,
yes.
When you are picking the pallet, are you using any special plugin to handle the collision between the robot and the pallet, or is it everything just handled by Gazebo regular plugins? The collisions.
Plugins, but I reduced the contact points.
Okay.
Only this.
Okay.
How did you reduce the contact points? What do you mean by that?
There is a tag in which there is the contact point about the surface with another surface, and I reduce it to 10 from 10 to 5.
Okay. And why did you do that?
Sorry?
Why did you do that?
Because I suppose that when sometimes I work with Gazebo, there are like the vibration of the part, and I used all the feature that I study in the course. It's important use collision, transparent, and I reduced this point, and I have not a problem with vibration of the part.
Okay. Yeah.
When the part go to react.
Yes, yeah, but it's correct. This because I presume that the question comes because usually it's very problematic in Gazebo when you have contact parts, and then by reducing the contact points in this way that you did, then you are reducing the amount of errors. A part of also of physics, you are simplifying the physics, the contact physics, but also is true. It's very problematic when two surfaces collide in Gazebo, and Gazebo doesn't manage that well. So good solution.
Yeah, so also here there is another interesting question. So is this project able to control multiple robots at the same time, or it is limited currently to only one robot?
Well, at the moment, I don't think I don't structure the project thinking to a fleet of robot, because I knew that the time was not so long to begin a project so difficult, and really I don't know if it's simple. For example, if I would use two robots, sure I can use two different robot description when I launch the robot. So if I have two description, no, I have no problem to visualize two robots, for example, in Gazebo. But the problem that I don't know at the moment if I create two move-based node can live together inside. I don't know. But I think maybe the fact that there is a package like RMF maybe that manage the fleet is a limitation to use more than one move-based node.
Well,
I think.
you need to separate the move base, for example, and the localization and all those topics into namespaces. So the names of the nodes need to be different. So you need to create a move base 1, for example, and a move base 2. So because if they have the same name, you know that they will collide and then crash.
Yes.
And also the name of the topics of each one of the move bases and localizations, they need to be changed, configured different.
Yes. For example, when I create a controller, I use a namespace as I create AMR, so I can use for create another controller. I change the namespace AMR2 and leave all the same.
Yeah, something like that.
Yes.
Okay.
I have one last question.
Okay, go for it.
Also, so in the process of detecting the palette and going all this approach sequence, it seemed like it was very slow, a bit cumbersome. It was doing this. It was first aligning, doing a full rotation to align laterally, and you mentioned that this process you think it can be improved. So, in which ways do you think that you can improve this so that all this process is done more faster and it's more clean in general?
Yes, I think that I can use after I thought that I could use the robot, the control in which I see the controller using the state space control. The state space control as I study in the course. For example, to be faster, I can use because for me is a normal proportional control. But to be faster, it's possible use a more big gain. But if I use a more big gain, I have a problem with the stability. So I think that it's important to integrate a PID to reach goal position more precisely and maybe faster. I was thinking about another way to reach to solve this goal, and I think that the solution is on the course. Is in the last part of the course there is a control in which I don't know if I remember the name, but in which there are the parameters to tuning the. And I did an exercise about this.
The potential fields? No.
I don't use there are another motive, because if I use this when the problem, this is a robot, this is no a cycle.
Yeah, it's not a differential
not
drive.
Yes,
I mean,
this is
it's differential drive, but it's not. Yes, a circle.
Yes, because I thought to use an algorithm that move the robot, but the algorithm is easy when the robot is little, but if rectangular has the fork, is not so same. So I was afraid to lost time, and I use this let me maybe trivial solution to move the robot, because I'm afraid I was afraid to lose time, and I create this one. Yes, there is very basically algorithm, because there is only a gain, and but sure I want first use another critical of the project is that I use a server. I was to use an action server, because if I know that the robot go in a wrong direction, because I know the position of the robot, I know the position of the pallet, so I can stop the robot and say go home, go forward. So the navigate move the robot in the start position. The robot can try again to fork in this way. If something goes wrong and the robot go in a wrong direction, I can stop the robot. This is another improvement, I think. So I want to continue to work maybe there are other people that I like to much study Git. I like to much study Docker. Docker is super. Docker is super.
That Chris also said the same thing before on his presentation. Okay, so in any case about the algorithm, the interesting thing is that you show us that it worked, and then that's true. When you have some constraints in your project, you have to decide at the end where to dedicate your time, and the most important thing is that you deliver. So you show something that works, and then that's what you showed here in your project.
Yes.
Then
I finished it yesterday.
Okay, but you don't have to tell us this. Less points. No, just joking. Very, very good job. Okay, so I think that was the last question. We have so many more, but I mean, we are out of time, so...
I think we can finish it here. Thanks to Salvatore, also thanks to Chris for their presentations and for all the work that they've put through all this year, because all this started 1 year ago, more or less, one day up, one day down. So it's been a pleasure. I hope that you also enjoy it all the way. It's been hard. We know that it's been hard sometimes, but I hope that now that you are, also for us. So I hope that now that it's finished, you have a good feeling about it, and you feel that like it's been time well spent, and that you have really learned a lot, which I think that you really have. So thanks a lot.
Thank to you. All your stuff. The construct platform is a very big educational tool.
Thank you very much. Thank you.
Thank you.
Thank you. And then now, what do we have to do now? What is the plan?
Now, nothing. Now, just close the streaming.
Okay. Okay. Yeah. No, but
no. Yeah. Now.
Explain what is this.
Yeah. Now we are going to deliberate between us and criticize a little bit your presentations, and decide. And grade them basically.
Okay. So, but now we close the stream, and then we are going to contact you later today with the final score. For you.
Actually, probably we are going to contact you actually next Monday with the final grade of the masterclass, including the final project presentation.
Okay.
So today we are going to decide the grades for this, but we are going to still meet and talk about it next Monday to decide the overall grade of the masterclass. So now you can already rest and take a free weekend. A well-deserved weekend. Free weekend.
Thank you, Salvatore.
Thank you.
Bye-bye, Salvatore.
Thank you. And for all the people there watching the stream, so this could be you, So if you are interested to have the skills about programming robots, those skills that will allow you to become job ready, to go straight into a job and know what to do, even if you are slow, but you know how to do it, then that's what we are offering at the masterclass. Remember, we are starting a new process, a new masterclass at the beginning of March. So which day is it?
7th.
On the 7th of March, we are starting, so you still have time to enroll for another year, or 6 months. It depends on you, of the speed that you want to move. And that is all.
Yeah, so I hope that you've been encouraged by these presentations and you join us in the next or following master classes that we are going to be doing. So thanks to all of you for being here with us, and we will see you soon. And until then, as always, keep pushing your ROS learning. Bye-bye.
Bye.
Thank you. Thank you.
Hey, thanks.
Yeah. Yes.
Okay, great.